Hi everyone, and I'm Upashna Mishra, and welcome to my educational channel, The Funda. So today we are going to learn about inserting some arithmetic means between two numbers, and also about the sum of the terms of an arithmetic sequence. So, what is the meaning of inserting arithmetic means between two numbers? So let the two numbers be A and B. Okay. A and B are two numbers, and say A1, A2, A3 up to AN are some n number of numbers. So if A, A1, A2 up to AN and B, so if this whole sequence is an AP, so we have chosen n numbers, that is A1, A2 up to AN, such that A1, A2, AN and B, this whole series is an AP. Then we say that A1, A2, A3 up to AN are arithmetic means inserted between A and B. Okay, so if A1, A2, A3 up to AN are n numbers, and if A1, A2, up to AN and B, so if this whole series is an AP, then A1, A2 up to AN are known as arithmetic means inserted between A and B. Okay, simple. This is the definition. So don't be confused by the word that arithmetic means. We defined in the last class that if A, B, C are in AP, then C is the arithmetic mean of means A plus C by 2 equal to B, and B is known as the arithmetic mean between A and B. So this is another way of representing. It is I think this the concept are in a different way. So just the definition, this is what the whole concept is. We just call those numbers A1, A2 up to AN as arithmetic means. Okay, nothing else. This is simple. Okay. So now you have I will give you a question. From this definition, you try to solve this question. So the question is, insert 20 arithmetic means between 4 and 57. Okay. So think about the definition, think about all the formulas that we used, like the formula for nth term and all that we have learned. So try to solve this question. Just pause the video and try to solve this question. Don't be in a hurry to know the answer. Just be patient and solve this question. Okay. So the answer is, so now we have to insert 20 arithmetic means between 4 and 67. So let those 20 arithmetic means are A1, A2, A3 up to A20. So these are all the 20 arithmetic means. That these numbers are known as arithmetic means between 4 and 67. So if A1, A2 up to A20 are arithmetic means between 4 and 67, then 4, A1, A2, A3 up to A20 and 67. This whole series is an AP. This we got from the definition. Okay, what we discussed last. So if this whole series is an AP, so count the number of terms in this whole AP. Sorry, this AP. So calculate the number of terms in this AP. So these are 20 terms and 2 extra terms, that is 4 and 67. So total 22 terms. 22 terms. So for finding A1, A2, A3 up to A20, we need the common difference of this AP, this whole AP. So let's say the common difference between 4 and A1 is D, and between this is D also. So we have to find the common difference to know what is A1, A2, A3 up to A2. So how we are going to do that? So as we know that there are 22 terms in the previous AP. Okay. And the last term is 67. Okay. 4, A1, A2 up to A20 and 67. So the last term is 67. So what is the formula of last term? So it is A plus n minus 1 D, formula for nth term. And nth term here it is the 22nd term. Okay. So A is the first term, n is the nth term, and D is the common difference. So 67 equal to 4 plus 22 minus 1 into D. Okay. Simple. So 63 equal to, I'm just calculating this one, 21 D. So D equal to 3. Okay. So now we have got that the common difference of this whole series is 3. So what are the terms A1, A2, A3? So it is 4 plus 3. A1 is this, if this is D is 3, then A1 is 4 plus 3, that is 7. Similarly, all the terms is 7, 10, I'm just adding 3, 13, 16, 19, 22, 25, 28, 31, 34, 37, 40, 40, 43, 46, 49, 52, 55, 58, 61, 64. And the last term is 67, we already know. And the first term is 4, which we already know. And leaving this 2, this remaining, this whole set of numbers, 20 numbers, is the 20 arithmetic means between 4 and 67. Okay. So this is the way I calculated the arithmetic means. So by solving the previous question, we came to know uh, from that question we can know about a pattern or about a formula of how to find the arithmetic means between two numbers. Okay. So what is the formula? So let's generalize the thing. Okay. If A and B are two numbers and we have to insert n arithmetic means between A and B. Okay, so what is the formula for that? So let the n arithmetic means be A1, A2, A3 up to An. So these are the n arithmetic means. So from the definition, A, A1, A2, A3 up to An, comma B, this is an AP. So what is the total number of terms in this AP? So these are n terms, and these are two extra terms. So total is n plus 2 terms. And the last term is B. So last term D equal to A plus n minus 1 D. So n is n plus 2. So it is n plus 2 minus 1 D. This I am doing to find the common difference in terms of A, B and N. Okay. This whole thing. Just means recall what we did. For 22 terms we did last term 67 equal to 4 plus 22 minus 1, that is 21 D. Similarly we are doing this just in place of 22, it is n plus 2. Okay, so it is b equal to a plus n plus 1 into d. So d equal to b minus a by n plus 1. Okay, so now we have calculated the common difference, that is b. So what are the numbers a1, a2, a3? So a1 is a1 equal to a plus 1 time d, that is b minus a by n plus 1. A2 is a plus 2 into a plus 2d, that is a into 2 b minus a by n plus 1. Okay. Similarly, an equal to a plus n into b minus a by n plus 1. A plus n d, that means nth term is a plus n d. So it is d is b minus a by n plus 1. So if you want, you can remember this one. Okay, that whenever we are inserting n number of arithmetic means between two numbers, that is a and b, so the common difference is b minus a by n plus 1. B minus a by n plus 1. So by remembering this, you can quickly solve the questions. So immediately you know what is the common difference. So immediately you will add the common difference to a, and then you will get the series by adding the common difference. So it will be very easy for you. So if you want, then you can remember it. Otherwise, you can just assume the numbers that we did in the last question. That in that question we didn't know any formula, so we could calculate. So either ways you can do. Okay. So now we are going to learn about the sum of terms of an AP. Okay. So sum of terms of an AP. So there is a very interesting way of finding the sum of terms of an AP. Okay. So let the sum of terms be S. Okay. So S equal to, so the AP is, suppose A, first term is A, second term is A plus B, common difference. Third term is A plus 2B. So we know that last term is B. So last but one term is B minus B. Obviously, before B, the term will be B minus D. So before that term, it is B minus 2D. Okay. So this is our AP. Okay. So first term is A, last term is B, and we have found out some middle terms like A plus D, A plus 2D, and last but one term B minus D, B minus 2D. So now we have to find the sum of all these numbers. So one interesting thing that I'm going to do is I'm going to arrange these numbers, means I'm going to write this AP in the reverse order. Okay, so first I will write B, then I will write B minus D. Means I'm writing from here to here, okay. B minus D, third term is B minus 2D. Similarly, we will go on. Means this term is A plus 2D. Then last but one term is A plus B, and the last term is A. So the whole this AP, I have written in reverse order. Okay. So after writing in reverse order, if I am going to find the sum of the second series. Okay, the first series is S, so sum of second series will also be S, because we are just reversing the order of the numbers, so sum will remain same. So the sum is also S. So one interesting thing that you can notice here is that the sum of the first term of this AP and the sum of the first term of the second AP is A plus B. Similarly, sum of second term and sum of second term is A plus B. Here it is also A plus B. So, sum of any two terms means let's say nth term of first series and nth term of second series is A plus B. You can see it. Last term is also A plus B. If you are not sure, then you can just calculate another term of this AP. Like if another term is A plus 3D and another term of this AP will be obviously B minus 3D, because we are just subtracting D from all these terms and we are writing the AP from highest to the lowest. Okay, B minus D, B minus 2D, B minus 3D. So again the sum of these two numbers is again A plus B. So this is very interesting. So after adding these two APs, so now we are adding these two APs. So it will be 2S equal to A plus B plus A plus B plus A plus B, because all are A plus B. So this how many times we have to do? N times. Why n times? Because this series has n terms. This series also has n terms. Okay. So 2S equal to n into A plus B. Okay. So S equal to n by 2 into A plus B. So this is what we wanted to find. We wanted to find the sum of all the terms of an AP. So the sum of all the terms of an AP is S equal to n by 2 into first term plus last term. This is our formula. We have to remember it. Sum of n terms of an AP. It is n by 2 by first term and last. First term plus last term. This is the first term. This is the last. So suppose in a question we don't know what is the last term and we don't want to calculate also. So how can we do that? So if the last term is B and we have n terms in that AP, so B equal to A plus n minus 1 D. B is the last term, so total number of terms n. So nth term is A plus n minus 1 D. So we have to put this value of B in this equation. Okay, so it will be S equal to n by 2 into A plus n minus 1 D. I've just replaced B with A plus n minus 1 D. So it will be equal to n by 2 into 2A plus n minus 1 D. Okay, so this formula also you have to remember. S equal to n by 2 into 2A plus n minus 1 D. This one. Okay, this one you have to remember. S equal to n by 2 into 2A plus n minus 1 D. So this is the sum of n terms of an AP is S equal to n by 2 into 2A plus n minus 1 D. This you have to, this formula should be in your fingertips. Okay, you should be able to easily recall this formula. You just need to, means it should be on the tip of your tongue. Okay, every time. Okay, and also n by 2 into first term plus last term. Okay, so two formulas we have got. Sum of n terms of an AP is n by 2 into first term plus last term. Also, sum of n terms is equal to n by 2 into 2A plus n minus 1 D. Okay, simple. So let me write again these formulas so that you can take a note of it. So, S equal to n by 2 into first term, sorry, S equal to n by 2 into first term plus last term. Also s equal to n by 2 into 2a plus n minus 1 d. D is the first, a is the first term and d is the common difference. Okay, so d is the difference. So this is the whole formula. Okay, these are the two formulas we have got. Now let's do a question, a simple question actually. Find the sum of arithmetic series 5 plus 11 plus 17 up to 107. So we already know the formulas, so you may pause the video and solve this question. It's a very simple question. Okay, so the answer to this question is, so we have to find the common difference. So from here we can know that this is the AP, this difference is 6, this is also 6. So we know that the common difference is 6. Okay, so the number of, then we have to find the number of terms in this arithmetic series. So we already know that the last term is 107. So for the number of terms, 107 equal to 5 plus, let the number of terms be n. So 107 is the nth term, that is the last term. So n minus 1 into d, that is 6. Okay. So 102 equal to n minus 1 into 6. So uh, so n minus 1 equal to 17. So n equal to 18. Okay. So the number of terms in this sequence, in series, is 18. So what is the sum? Formula for sum? N by 2 into first term plus last term. So n is 18, n by 2 into first term is 5 plus last term is 107. So it is 18 by 2 into 112. Okay. So it is 18 into 56. That is 1008. It is 1008. 18 into 56 is 1008. So you can calculate this number. You can, if your answer is 1008, then it's correct. So let's do another interesting question. In a certain AP, the ratio of sum of first R terms to the sum of first S terms is R square by S square. Always. Always. For any R and S. Find the ratio of eighth term to the 23rd term. So now you may pause the video and solve this question. Okay. So what we are given in this question, that in a certain AP the sum of first R terms to the ratio of sum of first R terms to the sum of first S terms is R square by S square. Always for any R and S. So find the ratio of 8th term to 23rd term. So first we are going to use this condition. Okay, we will use this condition and we will try to get some means equation from this condition. So simply we will use this condition. So what is the sum of first R terms? It is R by 2, n by 2 into 2a plus n minus 1d. So it is R by 2 into 2a. We don't know let the first term of that AP be a. Okay. Plus n minus 1d. So it is R minus 1, and we also don't know the common difference because we don't know anything about that AP. Only this condition. So let it be d. So this is the sum of R terms divided by the sum of S terms. S by 2 into 2a plus S minus 1 into d. Okay. So we are given that this whole ratio is equal to R square by S square. So from here we will cancel 2 from numerator and denominator. Then this R and R, this S and S square. So it will give 2a plus R minus 1 into d by 2a plus S minus 1 into d equal to R by S. So what we have got? 2a plus R minus 1 into d by 2a plus S minus 1 into d equal to R by S. So now we are going to cross multiply this whole equation. So 2as plus R minus 1 into ds equal to 2ar plus S minus 1 into dr. Now we are going to open this brackets and we are going to try to solve this, what comes out of this equation. So 2as plus drs minus ds equal to 2ar plus drs minus dr. So this drs and drs cancels out. So now we are going to take s common. Okay, now we are going to rearrange this equation. So if we transfer it into this side, so 2as minus 2ar equal to ds minus dr. Okay, I just transfer this and this into opposite. So now we are going to take 2a common. 2a common. So it will be s minus r. 2a into s minus r. And if I take d common, it will be s minus r. So now s minus r and s minus r cancels out. So 2a equal to d. So this is a important thing that we learned about the AP. Okay. From the condition we learned that 2a equal to d in that AP. So now we are asked about the ratio of 8th term and 23rd term. So this becomes very easy because we already know the relation between a and d. That is the first term and the common difference. So let us see how we are going to use it. So 8th term by 23rd term equal to a plus n minus 1d. So n minus 1 is 7, 7d by a plus 23 minus 1d, so a plus 22d. Now we are going to use the condition that d equal to 2a. So in place of d, we are going to write 2a. So it will be equal to a plus 2a into 7, that is 14a, by a plus 2a into 22, that is 44a. So it will be 15a by 45a. Now the a cancels out. So it will be 15 by 45, and by simplifying it, we will get 1 by 3. So the ratio of 8th term to 23rd term is 1 by 3. Okay, simple. So this was it for this class, and in the next class we are going to learn about geometric progression. So hope you like it, and please like, share, subscribe to my channel, and also press the bell icon to never miss an update from my channel.